All right. So if you don't know anything about acid-base properties of salts, I would invite you to look back on the video that is the explanation of acid-base salts before you tackle this, because it could be a little bit tricky. What they're asking us to do in this particular problem is they're asking us to rank these from the lowest pH to the highest pH. So the lowest would be 1 and the highest would be 4. Now the question is, how can we take a look at these guys right here and determine whether or not they are acidic or basic? And the way we do that is we kind of break them apart and see what they are compared to their conjugates. Now, what do I mean by that? Well, let's take the first couple as an example here. So let's take a look at NaCl. So NaCl in reality is Na plus and Cl minus. Agree? So if we take Na plus, we know that that is the conjugate of NaOH. Another way of thinking about this is when you have the positive ion, think about what it would be with an OH. Now, if you take a look at the rules for solubility and whatnot, NaOH is definitely a strong base, which means that this Na plus is a terrible, terrible acid. In other words, it's not going to do anything in terms of grabbing hydrogens or doing anything like that. So the Na portion of this right here is going to be neutral. It's not going to do anything. Similarly with Cl minus, think of it if we put an H in front of it, what would the strength of that acid be? And remember, the stronger your acid, the weaker your conjugate base. HCl falls in the category of a very strong acid. So therefore, this is going to be, again, a really pathetic base. So that means that both the Na and the Cl, they both are going to do nothing of what their jobs are. In other words, Na plus is not going to be a good acid, and Cl is not going to be a good base. So essentially, you have a neutral compound. So in our minds, we're going to look back at our table, and we're going to think to ourselves, all right, this is neutral, right? Now let's take a look at the next one, NH4Cl. Now, NH4Cl. Now, we've just seen Cl a second ago, right? And isn't Cl the conjugate of HCl? So this Cl right here, we can say to ourselves, that is going to be neutral. So then we have to take a look and see what NH4 can or can't do. So NH4 is actually NH4 plus. And isn't that the conjugate of NH3? Remember, conjugates are essentially one hydrogen off from each other. So we know that NH3 is a weak base, not a strong base. So therefore, this is going to be a weak acid. This is actually going to be acidic. So we know that NH4Cl, this is going to be acidic. The trick way of doing this, and I know this is not exactly the way it's supposed to work, but what you can do is you can take the first thing in each one of these, and you can put an OH with it, and you can take the second thing and put a H plus in front of it and determine whether or not they're going to be strong or weak acids or base conjugates. So let's take a look at the next one, KCH3CO2. Now, I'm not going to go all the way down to the bottom there because I have it right here, but I'm going to write it over here. So if we take K, wouldn't K be the conjugate of KOH, right? So we know that K in this case is going to be neutral. And then if we take a look at the CH3CO2, right? That, however, if we were to put in front of it, CH3CO2, if we were to put an H in front of this, would that be a strong acid? No, it's a weak acid. So therefore, this right here is a weak base. So what we have is neutral right here, and we have weak base right here. So this is going to be basic. And then lastly, we have, again, kind of similar to what we had at the beginning, we have Na and we have Cn. Now, remember, we said before that Na is the conjugate of NaOH. Therefore, Na is a pathetic acid. And it might help you if you think about it like on a teeter-totter. So you have on one side of it, you have your Na plus, and on the other side, you have your Cn minus. And we want to know which one of these is going to be better at its job. Na is a pathetic excuse for an acid. It's terrible at its job. Cn minus is the conjugate of HCN, and HCN is a weak acid. Therefore, this is going to be a weak base. So what do we have here? We have a bad acid, and we have a weak base. So what is this bottom one here going to be? It's going to be basic. So when we're comparing all these things to each other, we're going to look at them and determine which one of these are going to be, which is going to be the lowest pH and which one's going to be the highest. Now, would you agree with me that the only thing we have right now that is acidic, in other words, that's going to be the lowest one, is this one right here, this guy right here. So that means that this has to be the lowest pH. So we're going to put this one here as 1. Now, these two over here, the bottom two, they are both going to be basic, right? And if they're both basic, they're going to be above 7. So the thing that's neutral, which is exactly 7, that's going to have to be our second ranked one. Now, here's where it gets tricky. Because if we take a look at this, both of these two right here, we've determined that they are basic. So what we have to do is we have to look over here and see what they're conjugates of. So if we take a look at HCN, wouldn't that be the conjugate of NaCN or the CN minus? And if we took a look at HCH3CO2, wouldn't that be the conjugate of the CH3CO2 minus? And if we take a look at both these right here, whatever one has a greater Ka will be stronger. So if we take a look at these two, acetic acid or CHACU, it's written kind of weird right there. CHACU is the stronger acid, which means that its conjugate base will be weaker. So of these two right here, this here is going to be a weaker base than this here is. And therefore, if we do the order, it's going to end up being like this. 3 and then 4. The reality is you're going to have to try and practice on these a little bit to feel good about them, but hopefully this has helped just a little bit.